is square roots. We are going to first talk about a little bit of vocabulary. That symbol that you put over top of a square root is called a radical sign. If I talk about the radical sign, that's what we're talking about. You need to know the vocabulary. The number underneath of that symbol is called the radicand. We talked about the radicand. That's the number underneath of the radical. Now, if I take the square root of 9, what do I get?
3.
That's called the principal square root. Now, you need to write down, I have it up here, I had it on the backboard, a list of the perfect squares.
2.
1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. 12 squared is 144. 13 squared is 169. 14 squared is 196. And 15 squared is 225. Okay? Those should already be committed to memory. If they are not, do so. You need to know those. In order to do this well, you need to have that in your brain handy. Now, it's on the whiteboard too. Okay. So the properties of the square roots that we are going to use today are a multiplication property that says, first, the square root of a times b is equal to the square root of a times the square root of b. So if I have a product, then I can take square root of one part of that, or one factor, and the square root of the other factor, and that will equal the square root of the product. The second one is going to be for quotients, or fractions. The square root of a over b is equal to the square root of a divided by the square root of b. So I can take the square root of each part and have it be still the same number. Questions on that? That should be familiar. You've used that before. The next one, when we simplify a square root, it has 3 properties. The first property of a simplified square root is that no radicand has a perfect square factor other than 1. That means if I write out all of its factors, none of them is a perfect square. Number 2, in every simplified square root, no radical will be in the denominator. Number 3, lovely. Number 3, no fraction will be left under the radical sign. So we'll look at examples to see what we're talking on each one of those. Okay, I know there's a little bit to write there, quite a little to write there, so I'll wait a minute until I see you guys get done writing before we move on and look at a whole bunch of examples today. Are we ready? Examples. Like I said, lots of them today. Number 1, square root of 20. What perfect root goes into 20?
No, 416. 4.5.
I'm going to take 4 times 5 is equal to 20.
2 root 5.
So, yep, we're going to go through all the steps, at least on this first one. I know you're ahead of me here, but that's okay. We're going to go through them. Square root of 4 times the square root of 5. So the square root of 4 is 2. So the simplified version of that is 2 root 5. Now, let me talk about showing your work here. If it's one you've seen a lot of and you just know it, you can feel free to just write 2 root 5. If it's one that is a bigger number, I want to see the way you factored it, and then write your 2 root 5. So show your work as you work through the problem. If indeed it's, like I said, 20, 12, those are some we see quite often, you kind of learn those. So these other ones, I want to see where you factored them and how you solved the problem. Okay, number 2. Square root of 75. What perfect square goes into 75?
25.
25. So that is the square root of 25 times 3. I'm going to skip this next step this time. I take the square root of 25, and I get 5 to 3 stays under the square root. Any questions? Problems? Okay. 200. What perfect root goes into that, or perfect square goes into that?
100.
So I have 100 times 2. Square root of 100 is 10. So I get 10 root 2. Now, just to help yourself out, as a convention, I try to write the perfect square first when I write the factors. That way, when I take the square root, I don't get confused and say, okay, which one stays underneath the radical, which one comes outside. It's the first one I take the square root of, so it's the one on outside of the radical. Okay, so do yourself a favor and just write that perfect square first. Okay. Next one. Root 5 times root 6. What do I need to do here?
Get root 30.
Get root 30. Since they're both underneath of the square root sign, you can multiply them. So that's the same as root 5 times 6, which is the square root of 30. Now, if one's not under the root sign and one is, you can't multiply it, but if they're both underneath of there, then you need to multiply them, okay? Now, make sure that you check when you get to this point. Is there any perfect square that goes into 30?
No.
No. So then you're done. If there is, you need to go ahead and take that next step, and sometimes there is. Okay, so root 5 times root 5, what's that?
Wait, is that 5 or 50?
5.
It's going to be, that's going to be 5.
It's going to be 5
don't even
because
have to
5
work
times
that one
5 is 25, so I get root 25, which is 5. Now, if I have root 7 squared, what's that? 7. If I have the square root squared, those two are inverse functions. They cancel each other, and so it's just 7. Okay, the squared and the square root cancel each other. Questions on those? Okay, now we're going to use this property, the 5 and 6 here, when we talk about our fractions. Okay, next one. Number 7, root 2 over root 5. Anybody remember what we need to do to rationalize the denominator? Remember, no roots will be left in the denominator.
Probably times by root 5. Both top and bottom.
Yes? Okay, I'm going to multiply the top and the bottom by root 5. Now here's why. I look at the denominator, it's root 5. I need to multiply it by something to make that root go away. Well, root 5 times root 5 is just 5. Root 2 times root 5, they're both under the square root sign, so that's going to be root 10. Now be careful, remember, if I'm going to change the form of this fraction without changing its value, I have to multiply by the same thing on the top and the bottom. So anytime you multiply by root anything, it has to be top and bottom with the fractions, okay? Unless you're changing something. Okay, so that's simplified. This one I need to rewrite what I have there. So this should be 21 over root 3. So 21
Times our root 3.
times by root 3 over root 3
So you're gonna get
times root 3 over root 3, not equals. Okay, so 21 times root 3 is 21 root 3. Root 3 times root 3 is 3. Now you have to simplify the fraction.
7.
Yep, 3 goes into 21 7 times. So I get just 7 root 3 over 1, which is just 7 root 3. So you simplify them just like you would a fraction now. If they're both outside the root sign, you simplify them like a fraction. If they're both under the root sign, you simplify them just like any other fraction. You can't go between the two, okay? Either have to both under the root sign or both outside the bracket. Okay, next one is negative 8 over 2 root 20. Now, there's going to be several steps in this no matter how you do it. But what's the most obvious thing to start with?
You should divide 8 2 by.
Yeah. Okay, 2 goes into 8 4 times.
It's negative 4 over root 20.
So we're going to have negative 4 over root 20. Now, let's simplify the bottom next. If I simplify root 20,
Take 5 root 5 times 4.
okay, it's 4 times 5.
2 root 5.
So that's 2 root 5. Okay, so I'm going to rewrite my denominator as 2 root 5. So I've got negative 4 over 2 root 5. I can simplify my fraction again.
Leaves 2 over root
2 goes into 4 2 times. So I have negative 2 over root 5. Last step. I need to rationalize the denominator. So I'm going to multiply by root 5 over root 5.
5. You get 2 root 5 negative 2 root 5 over 5.
So 2 times root 5 is negative 2 root 5. Root 5 times root 5 is 5. Yes.
When you got back when you got like negative 4 over root 20, what
Yeah.
if you just like multiply by?
You could write by root 20 over root 20. Absolutely can do
Do
that. But then you'll have to simplify it on the top then. Then
So it's just more work.
it's a different order. But as long as you do it all, it'll still come out the same. You could do that first. No problem. Okay, any other questions? Okay. So let's keep going. That's more. Okay, more fractions. I have 1 over the square root of 36. That is the same as the square root of 1 over the square root of 36. Well, the square root of 1 is 1. Square root of 36 is 6, so I just have 1/6. So remember, fractions or products, you can take the square root of each part, or you need to take the square root of each part separately. Now on the next one, it's probably going to make more sense to simplify the fraction first. So 2 divided by 24, well, 2 goes into 2 once, 2 goes into 24 12 times, so I get the square root of 1/12. Well, that's the square root of 1 over, well, the square root of 12, what's perfect?
3. 4,
Okay.
4 times 3.
4 times 3, because 4 is a perfect root, so I get 1 over 2 root 3. So then I'm going to multiply top and bottom by root 3. So I get root 3 over 2 times root 3 times root 3 is 3, or root 3 over 6. Okay, yes, some of them are going to have some steps to them. You need to do them all. let's see, 3 references, 2. Okay. Actually, before I write these last two, I have another little quick lesson I want to do with you. We're going to put variables in here. And if I have a variable raised to an even exponent, say the square root of x squared. What's the square root of x squared?
X.
Just x. Remember, this root sign and the squared cancel each other. So that's just x. Now, if I have another even exponent, say the square root of x to the 6th power. Now, you have to remember some properties of exponents to make this work. But stick with me here. X to the 6th is the same as x to the 3rd to the raised to the 2nd power. Well, the squared and the square root cancel each other. That's just x to the 3rd. Now, you don't have to go through that intermediate step. I just wanted to show you that's why it is any even exponent. When you take its square root, you take half of the exponent. Okay, so x to the 8th would be x to the 4th if you took its square root. Okay, so that's the way even exponents work. Odd exponents. If I have the square root of x to the 3rd, I can rewrite that as the square root of x squared times x. Because when you multiply like bases, you add their exponents. That's you like x to the 1st. Well, the square root of x squared we just said was x. The square root of x is still the square root of x. Okay? So let's look at x to the square root of x to the 9th. Okay? We're going to make this an even exponent. That's the square root of x to the 8th times x to the 1st. Well, the square root of x to the 8th we said was x to the 4th times the square root of x. Okay, so that's how you deal with odd exponents. Questions?
So you always have x one.
When you have an odd exponent, there's always going to be a root x left, yes. If it's an even exponent, there won't be any root x left when you're done. Okay?
The odd, you want to get it to even so you reduce it by 2.
Right. Okay. You want to get it to even. Okay, so let's do a couple of those and then I'll be done. What number was I on? So number 12. So look at the square root of 3 x to the 3rd over 16 x to the 4th. Okay, the first thing you look at here is the numbers. Can I reduce that fraction 3 over 16 at all? No. So can't do anything with that. But I have x to the 3rd over x to the 4th.
You can reduce that down.
I can reduce that. If you remember, when you divide like bases, you subtract their exponents. So I take 4 minus 3 is 1. So I have 3 over 16x. Anybody not follow that part? That should be review, should remember that, hopefully. Yes? Okay. So then at this point, you break it into its pieces. You've got the square root of 3 on top, the square root of 16, and the square root of x. Well, what is the square root of 16? 4. Okay, so I've got root 3 over 4 root x. Now, I still have a radical in the denominator, so I need to multiply times root x over root x. Now, these are both under the radical, so I can multiply them. So I have root 3x over 4 and
X
root x
squared.
times root x. Now it's the square root of x squared,
I'll
which
stick it.
is x. Okay, so that's your simplified one. Okay, square root of 49n to the 4th. Well, what's the square root of 49?
7. N
What's the
squared.
square root of n to the 4th?
2.
Is n squared, okay? Okay, even exponents are nice with square roots. Okay? Square root of 36r to the 5th.
Well, you get 6.
Okay, square root of 36 is 6. And then I'm going to do this way just to get you this in the habit. I've got r to the 4th times r.
So 6r squared.
6r squared
To the r.
times the square root of r. Okay? Questions?